I'm starting to think that maybe my initial hypothesis of having a specialized AI for each field or each subject is wrong. And instead, I should look at it more like you have the layer one, which is like the core AI, and like Chad GPT. And clearly it has shortcomings, sparse data sets and for some fields, but it's the layer one. And then when you want to apply a layer two to it, that's when you use this synthetic data model, or whatever term you guys are using, to just basically describe more data on that specific subject that another AI already has or is generating. And that way you have this foundational layer one, and then you use your modular layer twos as needed for whatever field it is. That's an interesting approach too.
If that's the case, doesn't that imply that the flaw is really in the process of training itself, the algorithm for training, and that if you improve the training algorithm, then you would need to take synthetic data or generate synthetic data and then run it back through the model again?
Well, the problem is the model does not know ex ante where it should be interpolating more in its training set. So this is, in a sense, it's a prior that human beings looking at the training set have to know where should we be generating more synthetic data to help train the model further in a particular area. Now, I don't know enough about where this synthetic generation is happening, but you can imagine, for example, word problems. People really like to throw word problems at, GPT-4, but word problems maybe are not very richly represented in the data set. So it's very easy to generate synthetically these word problems, but maybe they just don't appear naturally very much, but it's the kind of thing that people would want to ask a chatbot.
Oh, this is very interesting. So there's another hidden input here, which is a human providing judgment on what area to focus on. Generate synthetic data in X is just saying focus more on the training data in X instead of, say, in Y. So that makes sense. Thank you. That is another hidden source of feedback from humans.
A couple of years ago, I fine-tuned ImageNet to fly around a little RC helicopter just to avoid walls and try to go where I wanted it to go. And a big part of that training pipeline that caused it to not act up was, like, specifically in computer vision, this works very well. You need to, like, warp the image a lot while providing the same output. So, like, you mirror the image and then you flip the controls, obviously, as well. Or you, like, make it the color red or something. Or you just try to encode with your synthetic generation that, like, hey, there's some commonality between all these distortions. Something about this image means turn left. I want you to, like, focus on going from that to turning left, not any of these other details. Don't focus on these details. And then at Comma AI, they're doing self-driving stuff. I'll put this in another chat. They have a deep learning pipeline that goes from image to where you drive, but they want to train it in a simulator so it corrects for driving noise, like bumps on the road. The simulator has certain artifacts. It would learn instead of actual, like turning when the car moves too much over to the right, it would learn like, oh, this specific little warp in the simulator, I should, turn left when I see that. It's like, no, that doesn't work in the real world. So while training, they have a separate model that's going from the image to a feature vector, right? And this is only trained on the real world data. And they penalize it for using too much information. So it's a very highly compressed vector that just represents semantically what you need to know to drive well. And then when they apply that to the simulator, it works perfectly. And it no longer corrects for stuff in the simulator. It looks at the simulator like it was looking at the real world. And it literally, the model that predicts where to go can't see the simulator artifacts, like they mask them. The driving model can't see the artifacts because the thing that it's seeing is not the actual video data. It's a model that goes from the data to a highly compressed semantic representation of just what you would need to plan where to go based on an image. And so it's kind of like it's looking at a very compressed form that compresses out the simulator artifacts. I just thought that was an interesting other way of people getting rid of this like fine-tuning on the wrong thing.